In this question, we want to find the standard deviation of the following graph. Now, in our graph, we have the frequency on the y-axis and its score on the x-axis. And to find the standard deviation, we want to use this equation below, which states the standard deviation equals the square root of the sum of a value minus the mean squared, all divided by the total number of values minus 1. So to solve this problem, we first want to find the mean of the graph. Now remember, the mean is the sum of all values divided by the total number of values. Now remember, the frequency tells us how many times the score appears. So to find the sum of all values, we take the score and multiply it by its corresponding frequencies. So we have 1 times 30 plus 2 times 50 plus 3 times 20 plus 4 times 10, and finally plus 5 times 40. And this sum is divided by the total number of values. The total number of values is all the frequencies added up. So we have 30 plus 50 plus 20 plus 10 plus 40. And if you solve this in your calculator, you get a mean of 2.87. So at the top here, we'll write our mean is 2.87. Now we also need to find n, which is the total number of values. Well, our total number of values is also the denominator of our mean. So 30 plus 50 plus 20 plus 10 plus 40 gives us a value of n to be 150. Now that we found our mean and our total number of values n, we can start to fill out the table. The first column in our table is the score. From our graph, we have a score of 1, 2, 3, 4, and 5. Now the next column is f, which stands for the frequency. The frequency for a score of 1 is 30. The frequency for a score of 2 is 50. And the frequency for 3 is 20. The frequency for 4 is 10. And the frequency of 5 is 40. Now our next column is x minus mu, where x is our score and mu is our mean. So x is 1 minus mu, which is 2.87. And 1 minus 2.87 gives us a value of negative 1.87. Now in our next row, our x is 2, and the mu is 2.87. And 2 minus 2.87 gives us a value of negative 0.87. Now if we continue this for the next row, we get 3 minus 2.87 to give us 0.13, 4 minus 2.87 to give us 1.13, and 5 minus 2.87 to give us 2.13. Now in our next column, we have x minus mu all raised to the power of 2. So we take our value from the previous column, which is negative 1.87, and we raise it to the power of 2. Negative 1.87 squared gives us a value of 3.497. Now in our next row, we have negative 0.87 raised to the power of 2, and negative 0.87 squared gives us a value of 0.757. In our next column, we have 0.13 squared, which is 0.017. In our next column, we have 1.13 squared, which is 1.277. Then we have 2.13 squared, which is 4.537. Now in our final column, we have f, the frequency, multiplied by x minus mu squared. Now our frequency in this column is 30, and we multiply that by x minus mu squared, which we solved in the previous column to be 3.497. 30 times 3.497 gives us a value of 104.91. Now in our next row, we have the frequency of 50 multiplied by x minus mu squared, which is 0.757. 50 times 0.757 gives us 37.85. Now if we complete the rest of the column, we have the frequency of 20 multiplied by 0.017 to give us 0.34. In our next row, we have 10 multiplied by 1.277 to give us 12.77. And finally, we have 40 times 4.537 to give us 181.48. So now that we've filled out our table, we can use this to solve for the standard deviation. From the equation, the standard deviation is the square root of the sum of x minus mu squared divided by n minus 1. So because we're dealing with a frequency, we have to take the sum of frequency multiplied by x minus mu squared. So the sum of this column is 104.91 plus 37.85 plus 0.34 plus 12.77 plus 181.48. And of course we divide that by n minus 1. We solved our n to be 150 and then minus 1. And of course we take the square root of all this. So if we simplify our numerator, we get a total of 337.35. And 150 minus 1 is 149, and we take the square root of that. So the square root of 337.35 divided by 149 gives us a rounded standard deviation of 1.5.